Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm James Titko. This week's question comes in from listener Bert.
How do new species come about without falling victim to inbreeding problems?
Thank you so much, Bert. We call this evolutionary process speciation. And to help me with the specifics,
I'm Roger Butlin. I'm Professor of Evolutionary Biology at the University of Sheffield. There are various different ways in which new species can form, either where one population gets isolated, usually geographically, and diverges. The other option is essentially where one species occupies two different environments and natural selection adapts different populations within the species to different environments.
at what definitive point do you say that you've got a brand new species?
That is difficult. A classic example of this would be Darwin's finches in the Galapagos Islands. The islands formed volcanically, and so a new habitat was created. And then a few individuals colonized those islands from the South American mainland. And for many generations after that, they had no contact with the mainland, and so they evolved independently on the islands. And actually, smaller populations evolved independently on different islands, eventually forming multiple different species on the Galapagos.
And the other way new species can form is a case of populations living in the same place, but beginning to diverge to gain an advantage in the different habitats in that close geographical proximity.
Another form of speciation would be like in the coastal snails that we study, where some populations of the snails live in boulder field habitats where there are lots of crab predators, and other populations live on rocky headlands where there are very few predators, but there's very strong wave action. So those populations are selected to adapt in different ways. When they're exposed to predators, they grow large with thick shells, and when they're exposed to wave action, they grow small with thin shells.
What's the advantage of the small, thin shells on the rocks?
They're more streamlined and less likely to be dislodged by waves. They can also hide in crevices on the rocks.
And the bigger shells on the shore make it harder for the predators to break into them. That makes a lot of sense. But in that diverging case, is it right then that animals who start to develop new traits continue to breed with other animals as they evolve? It's more often a very gradual process, and that's why it's hard to point to an exact generation where we can say we're defining a new species now.
Yes, that's right. It's a gradual process. And often, perhaps, when a few individuals arrive in a new environment like the Galapagos Islands, the population was able to grow very quickly. There were lots of resources and few competitors. And because of that, the inbreeding problems were not so serious.
Thank you to Professor Roger Butlin from the University of Sheffield, and to you, Bert, for that interesting question. A bit of tidying up to do now, and we've heard from John in relation to a previous question of the week, where we were looking at the difference in time it takes to freeze either hot or cold water. Now, John correctly points out that heating removes dissolved gas and some temporary hardness too, which will raise the freezing point. So something else to bear in mind with regard to that particular comparison. Thanks for that, John. And we look forward to next week's question of the week. Here's what we'll be answering from Donald. Water that collects underground is used by humans and is often replenished by various precipitation, such as snow and rain. How did people find wells in the past? Or was it just dig till the water table is breached? Well, we'll be very intrigued to hear the result of that one. Come back next time. If you've got a question of your own, why not send it in to chris@nakedscientist.com. We'd be glad to take a look. That's all for this week's edition. Thanks for listening, and goodbye for now.